Good morning, children. I am Vijay Lakshmi, working as maths teacher at GBHS Thirumalgiri. Children, today we are going to learn about the basic operations of sets. We already know the basic operations of numbers, as you have plus, minus, into and division. Similarly, there are some basic operations for sets, but they are not plus, minus, but we have different names for them. So the basic operations of sets are union of sets, intersection of sets, difference of sets. If A and B are two sets, then the set of all elements of set A or set B is called as union of sets A and B. This is written as A union B and read as A union B or A cup P. So the symbol of union is U. In set builder form, we write it as A union B is equal to set of all x such that x belongs to A or x belongs to B. In other words, we can say that all the elements of A and with all the elements of B together is called as A union B. Now let us see some examples. In your example 1, A is equal to the set of all elements containing 1, 2, 3, 4, 5 and 6. B is the set containing 4, 6, 8, 10 and 12. Then find A union B. A union B is equal to, so we first write the set A with a symbol union and set B. So that is representing what is given in the problem. Then A union B, we are going to identify the common numbers. So 4 and 6 are common in both the sets. 4, 6 are in A and 4, 6 are also in B. So now A union B is nothing but we write all the elements of A. So 1, 2, 3, 4, 5 and 6. Now coming to B, 4 and 6 are already written. So we write the remaining 8, 10 and 12. We have already learnt that in a set elements cannot be repeated. So 4, 6 are common in both the sets. So we write them only once. Now coming to example 2. A is equal to set of all x such that x is even and x is less than or equal to 10. B is equal to 1, 3, 5, 7, 9. Then find A union B. So A is given in the set builder form. We have to write it down in a roster form. So there are two conditions for x, that is it should be even and it should be equal to or less than 10. So A is equal to 2, 4, 6, 8, 10 and B is already given in roster form 1, 3, 5, 7, 9. So when we take A union B, there are no common elements between A and B. So we write A union B is equal to set of all elements of A and then set of all elements of B. So we get 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. Again for our generalization, we write it as A union B in a systematic way, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now coming to the example 3. A is equal to set of all x such that x is equal to 3n, n belongs to natural numbers and n is less than 9. So x is equal to 3n means it is a multiple of 3. And how many multiples? Your small n is less than 9. That means you are going to take 8 multiples of 3. The next, in the second set, B is equal to set of all x such that x is equal to 6n and n belongs to natural numbers, n is less than or equal to 4. So here the set B denotes the multiples of 6 and as it is given as n is less than or equal to 4, we are going to take 4 multiples of 6. So now A will be 8 multiples of 3 and B is 4 multiples of 6. Now we are going to take A union B. We write set A, put a symbol of union, and we write set B. Now let us underline the common elements in both. So 6, 12, 18 and 24 are the common elements. That means we should not write them twice. We are going to write it only once. So now A union B is equal to 3, 6, 9, 12, 15, 18, 21, 24. Now here there is a small observation we are supposed to do. Now when you check B and A, all the elements of B are also in elements A. That is, B is a subset of A. So whenever you get B is a subset of A, we have got A union B is equal to A. We can generalize that if B is subset of A, then A union B is equal to A. So I think union of sets is clear now. We have taken 3 examples. We have taken roster form, set builder form, and then we have taken subsets, etc. Now let us go to the second operation of sets. Intersection of sets. If A and B are 2 sets, then A intersection B is the set of all common elements in both sets. We write it as A intersection B and read it as A intersection B. That will be the reverse symbol of union. In set builder form, we write it as A intersection B is equal to set of all x such that x belongs to A and x belongs to B. So children, you have to make a observation here. For union, we have written x belongs to A or x belongs to B. Whereas for intersection, we are taking common elements. Therefore, we write x belongs to A and x belongs to B. Now let us see with some examples. The first example, A is equal to alphabets A, B, C, D, E, F. And set B is equal to D, E, F, G, H, I. Find A intersection B. As we have written for union, we first write set A, put a symbol of intersection, and then we write the set B. Now A intersection B is equal to, in the second step, we are going to find out if there are any common elements. So we are going to underline them. So we observe that D and E are common. So we have underlined it. Now A intersection B is equal to set of only common elements. So we take only D and E. So here once again I repeat, we are taking only common elements for intersection of sets. Now coming to the second example, P is equal to set of all x such that x is even and x is less than 13. Q is equal to set of all x such that x is odd and x lies between 2 and 12. Find P intersection Q. So now P is given in set builder form, so we write it in roster form. So P is equal to even and it should be less than 13. That means it starts with 2 and it is going to end with 12. So 2, 4, 6, 8, 10, 12 are the elements of P. Now coming to Q, x is odd and it should be lies between 2 and 12. So after 2 the first odd number is 3 and before 12 the last odd number is 11. So it starts with 3 and it ends with 11. So Q is equal to 3, 5, 7, 9, 11. P intersection Q is equal to 2, 4, 6, 8, 10, 12 intersection. The set be 3, 5, 7, 9, 11. Surprisingly, there are no common elements in both the sets. So we don't have any elements in P intersection Q. So P intersection Q is going to be a null set. So P and Q do not have any common elements. Two sets P, Q for which P intersection Q is a null set are called as disjoint sets. That is, disjoint sets do not have any common elements. Intersection of disjoint sets is always a null set. Now coming to the example 3, R is equal to set of all x such that X is a factor of 12. S is a set having elements 1, 2, 3 and 6. Find R intersection S. R is equal to set of all elements 1, 2, 3, 4, 6, 12. So we have to write the factors of 12. 12 can be written as 1 into 12, 2 into 6, 3 into 4. So we got all the factors of 12. Now S is already given in a roster form. So now R intersection S, we are going to underline first common elements in R and S. So here we observe that elements 1, 2, 3 and 6 are also in R and S. So S is a subset of R. Now when we take R intersection S, we get the underlined elements 1, 2, 3 and 6, which is nothing but S itself. So R intersection S is equal to 1, 2, 3, 6. We can see that S is a subset of R and R intersection S is equal to S. Now let us go to the third operation. If A and B are two sets, then the set of all elements belonging to A and do not belong to B is the difference set A minus B. And similarly, the set of all elements which belong to B and do not belong to A is the set B minus A. In other words, we say that A minus B is nothing but all elements of A from which B elements are removed. We have to remove the elements which are in B. Similarly, B minus A, the elements of B are taken and from that the elements of A are removed. In set builder form, we write it as A minus B is set of all X such that X belongs to A and X does not belong to B. B minus A is equal to set of all X such that X belongs to B and X does not belongs to A. Now let us go for some examples. Example 1, A is equal to 1, 2, 3, 4, 5, 6. B is equal to 4, 6, 8, 10. Here both are given in roster form. Both are given in roster form. So directly we are going to do the problem. So we write A and B. With one single step we are going to get the answers for both. So let us see how we are going to get it. Now we write set A, we write set B. In both the sets we are going to underline the common elements. We see that 4 and 6 are common in both the sets. So underline both the elements. Now A minus B is nothing but all the elements in A which are not underlined, that is 1, 2, 3 and 5. And similarly B minus A is nothing but all the elements in B which are not underlined. So that is 8, 10. Now coming to the example 2. A is equal to set of all X such that X is a prime number and X is less than 15. B is equal to set of all X such that X is a vowel in English letters. So both are given in set builder form. We have to change them into roster form. So A is equal to all the primes which are less than 15. So primes start with 2. So the elements of A are 2, 3, 5, 7, 11 and 13. B is equal to the set of vowels A, E, I, O, U. Now we see that there are no common elements between A and B. So we can't underline any elements. So now A minus B is equal to all the elements remaining in A. So 2, 3, 5, 7, 11 and 13, which is nothing but again A. Similarly, B minus A is equal to A, E, I, O, U, which is again B. So we see that A and B are disjoint sets. They are not having any common elements. So in disjoint sets, A minus B is equal to A and B minus A is equal to B. Now coming to the third example, A is equal to set of all X such that X belongs to W and x is less than 8. B is equal to 1, 3, 5, 7. So set A is given in set builder form and B is given in roster form. So we change only A to roster form. So whole numbers start from 0 and they should be less than 8. So A is equal to 0, 1, 2, 3, 4, 5, 6 and 7. B is equal to 1, 3, 5, 7. Now we write both the sets A and B and we are going to underline the common elements. So 1, 3, 5, 7 are the common elements. We underline both in both the sets. So we can observe that all the elements of B are in A. That is, B is a subset of A. Now let us write A minus B. A minus B is nothing but all the elements which are not underlined. So 0, 2, 4, 6. Now B minus A, there are no elements which are not underlined, so it is going to be a null set. So when B is a subset of A, we observe that B minus A is a null set. We can say that set B is a subset of A and B minus A is equal to null set. We can generalize that if B is a subset of A, then B minus A is a null set. Children, I think it is clear now. We have learnt about union, intersection and difference of sets with various examples. Now coming to the summary of the class. So what we have learned today. So first one, if A, B are two sets, then the set of all elements of set A or set B is called as union of sets A and B and written as A union B. If A and B are two sets, then A intersection B is the set of all common elements in both sets. We write it as A intersection B. If A and B are two sets, then the set of all the elements belonging to A and do not belong to B is the difference set A minus B. The set of all elements which belong to B and do not belong to A is the set B minus A. Now we have observed some special results. So if A and B are two disjoint sets, then A intersection B is going to be a null set. And A minus B is equal to A and B minus A is equal to B. If set A is a subset of set B, then A union B is equal to B, A intersection B is equal to A and A minus B is a null set. Thank you children for watching the video.